cannonball is fired with an initial velocity of 87 meters per second at an angle of 41 degrees as shown in figure C7. Find the position of the cannonball at the apex of its flight. Okay, so first order of business, draw a diagram of what we have to solve. So we have a cannon. And this angle is theta, and the initial velocity is VO. The trajectory is like this. So we're told that VO is the initial speed. Actually, initial speed is 87 meters per second. Speed, not velocity, speed. And find at an angle of 41 degrees, so theta is equal to 41 degrees. So we're going to use the equation. So what's the apex? The apex is the top, when the velocity is, so the ball is traveling, the cannonball is traveling on an arc. At the apex, it's traveling horizontally, so there's no vertical motion. Knowing that idea, I'm going to use the equation V final is equal to V initial plus acceleration times time. So V final, V initial is going to be equal to, so we have this is theta, so the x component is going to be equal to VO cosine theta I hat up. I'm sorry, I forgot to put directional vectors down, so I hat is along the x-axis and j hat is up. So VO cosine theta plus VO sine of theta j hat plus the acceleration times time is minus g j hat is the acceleration times time t. So we have I and we have j. So V final velocity at any time t, so maybe it's, we can write this as a function of time t, is equal to VO cosine of theta I hat plus j hat VO sine of theta minus gt. So all we know is that at the apex the velocity is horizontal, so if it's horizontal then this component must be 0. So at apex, what was the question again? Find the position of the cannonball at the apex of the flight. Okay, good. At apex there is horizontal motion only. Horizontal motion. And so this term, j, is not moving up and down, must be 0. So VO sine of theta minus gt must be equal to 0. T is unknown. So this tells me the time when the cannonball reaches the apex. So we solve for t. T is equal to, move the term to this side, divide by g. So VO sine of theta divisible by g. Let's call it AA for apex. So we've calculated the time to reach the apex of the motion. Once I know the apex position, right, I can use the displacement vector, position vector equation. So remember, the two general equations that you have to memorize for all constant acceleration problems are V final minus V initial over time is acceleration, equation number 1. Equation number 2 is a displacement equation that says d final is equal to d initial plus v initial times time plus 1/2 acceleration times t squared. These are the only two equations you need to memorize for constant acceleration problems, which basically is all college physics. Okay, so I'm going to take my origin to be here at the origin. So here's my y-axis, here's my x-axis, and so this is going to be the origin. So the displacement, the initial displacement, so the equation I'm going to be using is going to be d at final position, let's call it df, which is going to be the apex point, so this is the final position, is going to be d initial vector plus v initial vector times time plus 1/2 acceleration times t squared. So this is the second equation that you need to solve. So we know the initial position is 0, so I won't even bother putting it in. But the initial velocity is given by, we already calculated it, VO cosine of theta I hat plus VO sine of theta j hat times time plus 1/2 acceleration is minus g j hat times t squared. And that's the position for any time t. So there is an I component over here, and there's a j component, so a little double line, and there's a j component over here. So d final at position is given by VO cosine of theta times t, so I'll put the t in front, plus VOT sine, this is the j components, minus 1/2 gt squared times j hat. So this is the position of the particle, the cannonball, at any time t. All we have to do is plug in for t equals VO sine theta g. So we can find the exact position in space, exactly where it's going to be located. It's going off the screen. Actually, so I have to substitute t, this equation, into this equation, so I need to erase something. So let's do the I component first. I'll erase this on the left hand side, on my left hand side. Actually, because I'm pressed on time, and I think let's just solve this equation. Let's find the time t and just plug in directly the equations. So t apex is equal to VO sine theta, so VO is 87 times sine of 41 degrees over 9.8. So here's the calculator. Okay, here's the calculator. Okay, 87 times 41 sine divisible by 9.8 gives me 5.8 seconds. But because I'm going to just substitute these numbers directly into these equations, I need a higher precision, so I'm going to actually put this up to 5.24. 4 significant digits. Even though the answer is supposed to, final answer is in 5.8, I'm going to use 5.824, yeah, 19, so 24 seconds. So the position of the apex can be now plugged in as 5.824 multiplied by VO, which is 87, times cosine of, so it would be nice if you actually solved for t and plugged into this equation, but being practical for an exam, I think it might be best if you just plug in numbers at the last step. So I'm taking the value of t at the apex and plugging into this equation. So it's 5.824 times 87 times cosine of 41 I hat plus 87 times 5.824 seconds for t, sine of 41 minus 1/2 times 9.8 parentheses 5.824 squared parentheses j hat. Okay, so we didn't have to solve these equations, but it would be nice if you had spent time doing it, but it's very time consuming, but numbers we can actually do very quickly. Even though we can't verify the results, the equations are much better for verifying results, but let's plug it in. So this means that it is 5.824 multiplied by 87 multiplied by 41 cosine equals, I got the last number, which is 3.8 times 10 squared I hat. Is it on the board? Barely. And next equation is 87 multiplied by 5.824 multiplied by 41 sine minus 0.5 multiplied by 9.8 multiplied by 5.824 squared equals 166, which is 1.7 times 10 squared j hat. So this is the distance at the apex, so let's call it dA. And I forgot the arrows. And the whole answer is in meters. So the apex is 3.8 times 10 squared meters in this direction, this way, and a height of 1.7 times 7, or 170 meters up, and 380 meters across this way is the position. So you don't have to solve these equations, but it would be nice if you did, but in a time-constrained exam, I think it's best to just get the general equation and just plug in numbers into the equation. You have to rush.